Welcome students to PRADIP sir classes as PSC where logo can talk the physics. And students, we are in the Numerical King series, AC Verma chapter 29, question number 47 and 48. And if you first in that particular channel, then obviously go back to the previous one and where I completed from 1 to 46 as well as the chapter number 1, that is unit and dimension, and also chapter number 30, that is Gauss law. All the numericals are completed with a best concept, I think, and you also appreciate after seeing this. Okay, so let's without a different talk, let's start with 47, question number 47. And what is the questions? First of all, students, write down the question. A particle of mass small m charge q is thrown at the speed of u against a uniform electric field and how much distance will it travel before coming to momentary rest? How much distance will it travel? So students, there is a electric field. First of all, एक electric field है यहाँ पर. Okay, so there is an electric field along this direction, and if it is uniform, then you have to represent it with an equidistance arrow. अगर यूनिफॉर्म इलेक्ट्रिक फील्ड है मतलब इक्विडिस्टेंस एरो देकर रिप्रेजेंट करना पड़ेगा. और अगेंस्ट द इलेक्ट्रिक फील्ड अ चार्ज इज, एंड इट इज इलेक्ट्रिक फील्ड, एंड अगेंस्ट द इलेक्ट्रिक फील्ड अ चार्ज q is thrown along this direction. So the electric field, this charge particle can experience the electric field along this direction, and you throw this particle with a velocity u, with a speed u is given along this direction like that. But the charge particle experienced an electrical influence along this direction. And what is the value of this? So electric field is equal to force by charge, and force equal to q into E. Force by charge. So electrical influence, that particular charge particle can experience an electrical influence along this direction where, but you throw that particular charge against the electric field is given. Then you have to calculate the charge particle, the distance covered by this charge, कितना दूरी तक ये जाएगा. So at that point the speed is v, and when it is comes to a particular distance, suppose the charge particle come along this direction and it is s distance, so it is momentarily it is retarded because there is an opposite force is acting along this direction, so it is momentarily comes to rest. That is the final velocity is equal to 0. So s equal to, so v square equal to u square minus 2as, and here you have to calculate s, so it is u square minus v square by 2a. Okay, so it is u square by 2a, since the velocity, final velocity is 0. But here the force is F equals to QV, so force equal to mass into acceleration, we know that, and this is QV, so acceleration equal to QE by m. So acceleration equal to QE by m, and you can substitute here, so S equal to u square by 2 into acceleration, that is QE by m. So QE by m, that is m u square by 2 QE. So this is the final answer. And I think that you realize that particular numericals with a deepest concept. Okay, so charge, again I repeat again, and it is my character that hammered you again and again, so that the numericals is completely, I have to realize that particular numerical with by from the heart, bottom of your heart. Okay, so a charge particle is thrown anti-parallel with the electric field. Against means anti-parallel with the electric field, but electric field can exert a force of QE, but the charge particle, you throw that particular charge along this direction with a velocity u, with a speed u. So v square equal to, so the charge particle momentarily comes to rest after covered a particular distance s. So v square equal to minus, since it is momentarily rest, so retardation in place of acceleration, you have to put the sign, that is minus of a. So a is equal to u square minus v square by 2a, and the v is 0, so u square by 2a, and the force equal to QE. So you can easily calculate the acceleration, force equal to mass into acceleration, and substitute this, you can get the value of this. So after traversing a distance of mu square by 2 QE, the charge particles momentarily rest. So thank you, but you don't be at rest. Okay, so continue study and wait for the next one. Thank you.